Okay, we're going to walk through the reaction to show you how to make indigo, and this is a properly set up reaction flask. We have a round bottom flask, there's a stir bar in there, and we can adjust the stirring. It is clamped into place, and we have a condenser sitting on top just to serve as a little bit of room in case something were to go wrong. And I'm going to show you what goes wrong. So here we have the nitrobenzaldehyde ready to be added, sodium hydroxide, water, acetone. So what's the right way to set up this reaction? Well, that's boring. I'll show you the dumb and dangerous way of setting it up first. So we're going to pour in the acetone, and we're going to go ahead and pour in the water. And you may have noticed the water gets a little bit cloudy when I first pour it in. If you turn on the stirring, it may go cloudy briefly, but basically you have one nice continuous solution in there. I can now go ahead and add the nitrobenzaldehyde to this and wait until it all dissolves. Okay, I stopped the stir bar from stirring, so you can see the nitrobenzaldehyde sitting in there, bright yellow stuff, and we need to get it dissolved before we do anything else. So now I turn on the stir bar and we simply wait until it has all dissolved. So far, so good. There's nothing necessarily wrong with what I've done, except this reaction is exothermic, which means that when I add the sodium hydroxide to it, a whole bunch of heat will be given off. And when that happens, it has a tendency to come shooting out the top end of this air condenser. So, again, the problem is that once we mix stuff together, it will end up spraying everywhere. So I'm going to stop the stirring again. And now what I'm going to do is throw in all 3 pellets of the hydroxide at the same time. And again, this is a bad idea. Don't do this. But if I just throw in all 3 pellets of the hydroxide, and then I start the stirring, it will immediately start a vigorous reaction. And it takes a minute or two for it to really go nuts, but you'll see that pretty soon that will come shooting out the top end of the flask. As it heats up, there it goes. That's what you want to avoid. So, the way we chose to run this reaction is not the right way to go. You want to avoid some of that exothermic reaction. You want to avoid having it suddenly boil over like that. Okay, so we're ready to go again. You can still see the evidence of the previous reaction that blew up everywhere and making a mess. So now we're going to run this reaction in a little bit of a smarter way. Once again, we have the nitrobenzaldehyde ready to go, sodium hydroxide, water, and acetone. Now the problem with the reaction, and the reason why it did what it did, is because we simply mixed things together in the wrong way. There's too much energy when all of the components are present at the same time. One of the reasons why that happens is because the sodium hydroxide mixing with the water will just heat up like crazy. And then when you have the reaction go, that also will go like crazy. Okay, much like last time, I added the acetone, but this time I haven't added the water. So I've added acetone, and I've added the 2-nitrobenzaldehyde. Now I'm going to stir it, and you can see that it's all dissolved. So far, so good. So what are we going to do differently this time? Well, what we're going to do is we're going to put the hydroxide and the water together and allow all of that heat to form and then dissipate, and then we're going to add the water slowly. So I've put the sodium hydroxide pellets into a test tube, and then I'm just simply going to add the water to the test tube as well. And then I'm going to allow those two to mix in such a way that everything dissolves eventually. There's a couple of different ways you can mix solid and a liquid in a test tube. One is doing what I'm doing. Hold it loosely up at the top and then flick. That will cause it to mix. But that takes a long time. So the other better option for mixing is to take a pipette and then suck up the liquid and then squirt it down and do that a few times. And again, all we're trying to do is we're trying to get the sodium hydroxide to dissolve. And once the sodium hydroxide is dissolved, you'll notice that the water down here is probably a lot warmer than when it started. So this is part of the reason why the reaction is exothermic. It's just the dissolution of sodium hydroxide and water. Once it's all dissolved, you can add the sodium hydroxide and water to your reaction, and it will be under control. You won't have the same issues that you did. There won't be any significant exotherm that causes the reaction to boil. Okay, so now I've successfully dissolved all of the sodium hydroxide and water in this test tube, and I've successfully dissolved all of the 2-nitrobenzaldehyde in the acetone. So all we need to do now is to combine them. I'm going to pipette in the sodium hydroxide water solution through the condenser. And the reason why this will now be under control is I don't have to add very much at one time. You can see that I'm adding this so that it drips in, so it's what we call a dropwise addition. And I can do that and see if there's going to be some major exotherm, some major problem when the two solutions mix. I can make sure that I'm stirring vigorously, and this way things won't get out of control. So now I can go and grab some more of the hydroxide water solution, again adding it relatively slowly. And unlike last time, all of the reagents are not present at the same time, and they're unlikely to have the same explosion of heat that we saw before. So here we're going to show you the right way to set up a vacuum filtration. Once your reaction is done, as far as it's going to go, you're going to want a setup that looks like this. But you'll notice that as soon as we attach a hose to your filter flask with your beaker funnel on top, this has a tendency to tip over. So always, always, always make sure that you have clamped in your setup. So you're going to need a ring stand, a clamp holder, filter flask, hose, Buchner funnel, and filter paper goes in there. So the right sequence of actions is you put the filter paper on top. It won't be held in place by anything except the vacuum. So what we're going to do is turn on the water, full blast. And now you'll notice that if your setup is working well, that the vacuum is what holds the filter paper in place. Okay, so the setup is now ready. Filter paper held in place by a full vacuum. Our reaction mixture has been cooling on ice since we combined it with the water. So when it's time to actually mix the two together to filter, you swirl this to make sure everything's moving and then pour it in rapidly. And you'll notice that it comes pouring out the bottom fairly quickly as well. So the material we're trying to isolate is up there. It's dark blue, metallic solid with some brown edge around it. The filtrate is what has come through. It's sort of reddish brown. And you basically have to wait until the drips stop. So now would be an excellent time to go tear a watch glass, get the mass of a watch glass, and so that you can then transfer your material to the top. And by the time you're done with that and you're back, then this should be done dripping and ready to scrape out onto the watch glass.